Next, we're going to talk about what is called a reference angle. So before we even look at the definition, let's start on first example by taking this 345 degrees. I just want you to sketch in what that angle looks like. As a matter of fact, why don't we do that for all four of these? I'd just like you to sketch and place all four of these angles. Then we'll come back and look how to determine the reference angles. So 345, that's almost a full 360, but not quite. So I'm leaving a little bit behind. So something like that. Negative 120. So that'd be a negative 90 plus about another negative 30. So somewhere right around here. Sketch that one in. And then 100 degrees, well, that's going to be positive angle, so counterclockwise, a 90 plus about another 10, so something like that. And then lastly, the negative 200 degrees. So that's going to start here, always start here. Negative 180 plus a little bit more. So something like that. So just making sure we've got all those angles sketched in where they should be. All right. Now our reference angle. We're first just going to draw them and then talk about how you figure out how big they are. So the reference angle, going back up here to our description, is the angle between the terminal side of the angle you just drew. All right, so the terminal sides of the angles we just drew and the nearest x-axis. Meaning, I'm going to take this terminal side and I'm going to either draw an angle to the positive x-axis or to the negative x-axis. Which one? Always pick the smaller one. So that's not this big old thing I just drew. Get rid of that. There's my reference angle. Here, it's either going to be to this negative x-axis, or it's going to be all the way around to the positive x-axis. Well, pick the smaller one. There's your reference angle. Here, it's going to be either this big fella or this small fella. It's always the small one. And here, it's either going to have to go all the way back to there or to there. Always pick the small one. So a note on your reference angles, they should always be between 0 degrees and 90 degrees, because you're never more than a quarter turn away from your nearest x-axis. Now, how do you determine how big these angles are? For that, you just have to think a little bit. So think about this green portion. If I put this green angle together with this blue one we already drew, that would be all the way around, right? So the green one must therefore be a full turn minus the amount that I've already gone. So this green angle is a 15-degree reference angle. There it is. In this second case, if I put the blue and the green together, that would give me a halfway around. That'd be 180 degrees. More specifically, be negative 180 because of our direction. Well, I've already gone negative 120. So how much further do I have to go to get there? I've got to go another 60. Now you'll notice I'm just calling it positive 60. Your reference angles don't care about direction. Reference angles are always between 0 and 90. So whether you started with a positive or with a negative doesn't make any difference for this particular type of calculation. Okay, do a quick pause. I want you to figure out these next two, see what we got. Okay, for this one, together they make a full half turn. I've already got 100. That means this must be the other 80 degrees. And now this last one. So this one, it's a little bit different because the blue and the green together, they don't make a half turn. They don't make a full turn. What I do have is the blue is a half turn plus a little bit of extra. Well, notice this reference angle is that little bit of extra. So I need to see, okay, I had a 200-degree rotation clockwise. That means I went 180, which was the half turn, plus another 20. That leftover bit, that's what the reference angle is. So moral of this story, there's no one way that you calculate the reference angle. There's not a simple formula you can use every time. You need to be able to visualize, so make a quick sketch, and then reason to figure out what that reference angle is. Now, when you are measuring in radian, nothing really changes. It's just that you should give your answer in radian. So you have two strategies. Strategy one would be to say, okay, I'm going to convert this to degrees, then do exactly what we just did, and then convert it back to radian in the end. That will work. It does, however, take a little longer. So I want to show you a way to do this in radian the whole time. It's the same process we did before, but placing your radian measures of angles is sometimes a little bit trickier. Here's the strategy that I like to use. Think of this 4 pi over 3 this way. We'll come back to this one. It's got a little nastier denominator, so we'll save it. Think of it as 3 pi over 3s plus 1 pi over 3. So 3 pi over 3s plus 1 pi over 3. The reason to do that is that it makes it so much easier to draw your angle. Because this, the 3's reduce, this is just a half a turn. So this is saying go a full half of a turn plus another pi over 3. Well, how much is a pi over 3? This is where I need you to remember that pi is a half a turn. I want to do 1/3 of that. So think about this bottom half turn, and in your mind, kind of divide it into 3 equal parts and go one of them. It should look something like this. This is the angle for pi over 3. Now, when it comes to finding your reference angle, having written it out this way actually makes it pretty simple. I went a full half turn. My reference angle is this part. Well, that's that little extra bit that I had to go. That's my reference angle, 1 pi over 3. Let's go again here. So take a look at 7 pi over 4. I want you to write this as 4 pi over 4s plus 3 pi over 4s. This is just a half turn. Okay, so we got a half turn going on. This then tells me the fraction of the second half turn that I need to go. So 3/4 of the way. So let's imagine, take the second half turn, divide it into half, then divide those halves into halves. Okay, so these are my fourths. I need to go 1, 2, 3 more of them. There is my angle, 7 pi over 4. The reference angle is then this leftover piece. Well, how much is this leftover piece? Well, it's just, okay, it's almost to the next half turn. I had 3/4 of the way. That means I must need the other 1/4 of the way, which we'll write as pi over 4. Let's go again. Let's do this one next. When the angle's negative, nothing really changes. I want you to think of this as, so it's actually not a full half rotation yet. It's 5/6 of a half rotation. So think about dividing, so starting over here, we're going in the negative direction. Divide this into 6 parts. So cut it in half and then cut the halves into thirds. So here's 1, 2, 3. Divide that into thirds. 4, 5, 6. And I want to go 5 of those. So my angle is this one right over here. The reference angle is then this leftover portion. Okay, to get to that half turn, how much more did I need? Well, I needed this extra 1/6. I needed this extra pi over 6. Okay, this is actually, it's getting kind of fun, yes? Okay, let's go again. So 55 pi over 18. Okay, so that's 18 pi over 18. There's 1/2 turn. Plus another. So this gets me 36 pi over 18. That's 2/2 turns. Plus another 18 pi over 18. That's 3/2 turns. 18, that's 54. So I've got 1 pi over 18 left. So just using the denominator to figure out how many half turns we have and how much is left. So I've got 1, 2, 3 half turns. So 1, 2, 3 half turns. And now this extra bit. So you're taking this last half turn, imagine dividing it into 18 parts. So I'm not going to sketch them all out just because it would take forever. It's a little sliver. So make a little sliver. That's actually a really big one, but you get the gist, I hope. This reference angle is equal to however much that extra little sliver was. And that extra little sliver was this. It was the 1 pi over 18. Now, you're not going to hear me say this is easy. And if you're comfortable, if you're more comfortable in degrees, switch this to degrees, do it like we did up here, and then switch your final answer back to radian. You're going to end up in the same spot. I just want you to be able to skip that middle step of the double conversion.